Hello, I'd like to talk to you about factoring special quadratic expressions. In this video, the special quadratic expression that I'm referring to is what's called a difference of squares, and we will simply be learning to factor those differences of squares. And in order to teach you how to factor a difference of squares, what I first want to show you is what kinds of things do you multiply together that give you a difference of squares pattern that we will then learn to factor. And it turns out that those things that we multiply to give us differences of squares are what are called conjugate pairs. And I have several examples of conjugate pairs here that we're going to be trying to factor. And what I'd like to do is before I get to these, show you what happens when you try to multiply conjugate pairs. And this expression here is exactly what I'm referring to when I'm talking about conjugate pairs. You're going to notice that the two factors that we're multiplying involve the same numbers, a and b. Once you're adding a and b, and in the other factor, you're finding the difference between a and b. And that's all conjugate pairs are, is the sum and difference between the same pairs of numbers. And when you multiply conjugates, a very specific thing is going to happen. Alright, so let's go ahead and use double distributive property here. I'm going to multiply a times a and get a squared. I'm going to multiply a times negative b and get a minus ab. And then I'm going to distribute the b from the first binomial to both of these terms. B times a, that's a positive b times a positive a. I'm going to write that as plus ab. And then I'll have b times negative b, so I'll get a negative or minus b squared. Now, when you multiply conjugates, I hope you're paying attention to what happens with those middle terms in the product. Notice I've got a minus ab and I've got a plus ab. And those are opposites of one another, and so when I add them together, they're going to cancel one another out, and so I'm not going to have a middle term like I do most of the time when I multiply binomials with one another. I'm just going to get the product a squared minus b squared. And every time you multiply conjugates, you're going to end up, when you multiply what are called the outer terms and the inner terms, they're always going to be opposites of one another, like this, and they're always going to cancel out, and so you're always just going to end up with the first number squared minus the second number squared from those conjugates. And since you have a subtraction problem involving one perfect square minus another perfect square, that resulting product is what's called a difference of squares. And so if you can remember this, it really kind of makes this quite easy. Whenever you multiply conjugate pairs, you always get a difference of squares. It rhymes, that's why this is easy. Conjugate pairs give you a difference of squares. So back to the conjugate pairs that I had earlier that we were going to find the products for. Simply says write each product in simplest form. And I want to show you how easy this is. And we can do 4 of these in almost no time at all. So you'll again recognize that you have conjugate pairs whenever the two factors that you're multiplying have the same numbers, but once it's subtraction and once it's addition. It doesn't really matter whether the subtraction factor comes first or the addition factor comes first. Whenever you multiply these things, we're going to have an x times an x, and that's going to give us x squared. But notice that we're going to multiply an x times a positive 3 and an x times a negative 3. And if we added those things together, they're going to cancel out. So we're not even going to worry about those middle terms. We're just going to go ahead and skip ahead, knowing that those will cancel, and we'll multiply the last terms together, negative 3 times positive 3, and get x squared minus 9. All right, so there's our difference of squares there. Simply, when you multiply conjugate pairs, in order to get that difference of squares, all you do is you square the first number, square the last number in the two pairs, and subtract them. Okay? So here for x plus 9 times x minus 9, we're just going to square the x, we're going to square the 9, and we're going to put a subtraction sign between them. X squared minus 81. Super easy, right? Alright, then how about for 4x minus 7 times 4x plus 7? Well, square the first number. When you square 4x, you get 16x squared. Square the last number. When you square 7, you get 49, and we'll put a subtraction sign between them. And I've already shown you, when you multiply a minus b times a plus b, that you just get a squared plus b squared. So that's, minus b squared. A little bit redundant right there. That's how you multiply conjugate pairs. Doesn't get much easier than that. So let's finish off then by doing what the stated goal for this video was, and that's factoring differences of squares. And at this point, you should realize, of course, that in order to factor a difference of squares, what you're going to do is you're going to kind of revert them back to conjugate pairs. All right? Because we said whenever you multiply conjugate pairs, you get differences of squares. All right. Well, that's how this is going to work here. In order to factor x squared minus 49, we know that we're going to get conjugate pairs. And to figure out what those conjugate pairs are, we just take the square root of the two numbers that you see. Square root of x squared is x. The square root of 49 is 7. And you make them a subtraction problem once. You make them an addition problem once. There you go. X minus 7 times x plus 7. Feel free to multiply those two binomials to make sure that you got the same thing. But hopefully you notice you would get a positive 7x when you multiply these outer terms. A negative 7x when you multiply the inner terms. So they would cancel. And you'd be left with the x times x and the negative 49. Real simple, right? So here, for x squared minus 324, just what's the square root of x squared? Well, that's x. What's the square root of 324? That's 18. And so this time I'll put x plus 18 and then x minus 18. So surely you've got the hang of this already. Let's look when a is not 1. Still the same idea. I'm going to take the square root of 25x squared. That's 5x. I'm going to take the square root of 144. That's 12. And I'll make one factor the sum of those two numbers, one factor the difference of those two numbers. All right, one last example. Turns out this pattern can apply even whenever you don't have perfect squares in that subtraction problem. If you just have a quadratic term minus a constant term, you can always factor using that difference of squares patterns if you will take the square root of the first term. Now, the square root of 3x squared is the square root of 3 times x. The x is not underneath the radical. The square root of 169 is 13. I can make this the square root of 3 times x minus 13, and the square root of 3 times x plus 13. So there you have it. That's how you factor differences of squares. One of the easiest things that you're going to encounter in all of Algebra 2. But super important that you know it because it's a pattern that presents itself so many times in mathematics. All right, thanks for watching. See you later.